Yeah, hi. Here is the presentation about experimental and numerical study for the combustion and soot formation of the biojet field. I'm Shai Xiao, and my supervisor is Tian Bo and James Jukes. Here is the context. So my provision project presentation is based on three parts. The first part is the biojet field described. The second one is PIV system and PIV experiment. The third one is the confirm code details. So the first part is biojet fields. The biojet fields are have many different kind of biojet fields. So I will explain some of them. The first one is Fischer-Tropsch synthesis (FT). The FT using natural gas, coal, and lignosulfuric biomass as feedstock. The second biojet field is hydro process of renewable material for plants, such as plant and soil or grasses. The third biojet field is hydro process renewable jets, HRJ. The HRJ is made from used cooking oil. The first part is alcohol to jet or sugar to jet, ATJ or STJ. So ATJ and its jet term alcoholization is converted from a variety of different chemicals such as methyl, ethanol, biethanol, and a long chain of different fatty-based alcohols. The hydro process ester and fatty alcohols, HEFA oil and fats from both are made from both plants and animals. It includes vegetable oils. So let me describe about the smoke points of different biojet fields. In the right-hand picture, we can see that the HEFA have the highest shoot smoke points, and ATJ is lower than the jet one is the smoke cone for the biojet field blinds as a function of blinding ratio R. This is the shoot value from fraction profiles along the flame center line for biojet fields. We can see that like the JP5 and JP8 are the jet field. And JTA also the jet field. ATJ, FT, SPK, and HEFA are the biojet field. So we can say that the shoot volume fraction, the JP5 is the biggest, and JT and the JT, JT and JP8. ATJ have the highest shoot value fraction for the biojet film, larger than FT, SPK, and HEFA Calamina. Here is a table about NVPM emotion characteristics of aircraft gas turbine engine burning biojet fuel blinds. We can see that the FT, SPK, HEFA, SPK, SIK, or ATJ, SPK, and also like the jet fuel JP8 and JT1. There are the aromatic content, paraffin content, sulfur, hydrogen, dirty H or H/C ratio. So let me explain about aromatic. Aromatic is one part of the particular matter PM. So as the formation of the first ring is circumvented aromatics from polycyclic aromatic hydrocarbon (pH). The pH formation is highly correlated to soot formation. The first part is aromatic has not a linear relation with carbon number. It also need to be marked. Here is the global jets NVPM emission inventories. The global jets PM mass emission inventories offer assignment on annual biojet NVPM emission, especially the magnitude of NVPM mass emission. The aromatic hydrocarbons in fuel are critical NVPM processors. The aromatic free property of biojet fuels lead to NVPM mass and number emission reduction. The high temperature soot formation. The high temperature is different compared to the low temperature soot formation. The higher reactant temperature leads to higher soot formation, and alkanes are more sensitive to the temperature change than alkanes in the high temperature. The soot oxidation may be lower by higher reactant temperature. So when the same engine truss and different fuel types, the same fuel types, different engine truss. Look at the right-hand picture that JT1A1 and HEFA or idle and P85 at JT1. This picture is show the this picture is show the ground idle condition used JT1 fuel has the highest fuel frequency. This is the different sampling temperatures are denoted using different color. So we can see that here are like JP8 over JTL and JP8 over CTL, and this is the JT1 over FT. And this is the JP8 over FT, JP8 over JTL, and Jet8 over HRJ, or JP8 over FT. So the second part is describe about the Davis PIV system. So the Davis the PIV is the particular imagine velocimetry. So we use the Davis 10 software to calculate the particular imagine velocity PIV. The experiment, we use the camera of CX5. Has the CX5 camera has a linear resolution like 2440 times 2040. The Davis PIV kit have options to combine 64 times 64, 32 times 32, 16 times 16, and 8 times 8 pixels as an integration area. If we choose the 32 times 32 pixels to form an integration area and want to cover a total probe volume roughly 10 times 10 centimeter, there's another marked thing is the PIV laser use class 4 laser device. Here is a picture about the calibration, the PIV calibration example. We can see that this calibration photo, the x-set is xy, and the red part is the velocity. And how to determine the dirt T? Dirt T is dirt x over v. So 5 times 0.015 is the meter of the over 32 is we choose 32 times 32 pixels. The 0.04 is the velocity. The dirt T is the adjustment by altering the frame rate and consequently the laser repetition rate. Here is how to calculate the 32 times 32 pixels covered probe value roughly 10 times 10 centimeter for the integration area. Here is the PIV integration. The common integration size for PIV is 32 times 32 pixels. The cross correlation process normally have 50% overlap. Each integration window have 8 to 10 particles. Here is an experiment of setup for PIV. The PC and device platform, frame grabber, camera, and signal generator. The laser is about 532 nanometers, 30 millijoules over pulse max. The red part is tank and probe volume and shoot forming opticals, and there's a laser from the mirrors to the tank. Here is the tank and the pump or PIV experiment picture. Here is why we use confirm code. The confirm code can be determined mass, momentum, energy, gas phase, chemical species. The programming language of the confirm code is Fortran 90. MPI requires an internal compiler. It uses the Linux workstation for HPC, high performance computing. The shoot formation in linear diffusion frame can be determined. Here is a low Reynolds number confirm code. Results is same with the experiment, like 20 to 80 Reynolds number. For more than 80 Reynolds number, you can see that the experiment result is lower the confirm code result. The alkanes flame speed at same temperature and pressure condition, the methane is the lowest flame speed, ethane is the fastest. Here is the left-hand part is the no CHT, and the right-hand model 2 is the CHT mesh model. CHT simulation means part of the field tab is included for the in the computational domain. The conjugate heat transfer CHT model, conjugate heat transfer CHT is a mesh model in confirm code. CHT is implemented by the harmonic mean method to model the heat transfer between the field streams and the solid field tab. CHT is a model in airstream and field tab. Here is the left-hand side is no CHT and the right-hand side is CHT models. About the model of hydrogen and chlorine for the CHT models and no CHT models. The shoot production's lower sensitivity to alpha can be explained by the differences in shoot formation mechanism on the wings. pH adsorption is the predominant mechanism on the wings for the CHT model. For the right-hand side, making shoot formation on the wings less sensitive to alpha. In contrast, without additional pH production, HAC surface growth remains dominant on the wings for the no CHT model left by the high side. Tills the no CHT model can improve its prediction by increasing alpha. Here is another CHT temperature mesh model example. For the left-hand side and the right-hand side is the real picture of shoot wing. So here is another example in the article about C2H4 NH3 pH model using confirm code. It includes 148 species and 1376 reactions for the neokinetic model. Opposite flow frame model by CHEMKIN Chemical software. One of the important amino field is N20. It can be determined the chemical effect of NH3 on the flame. The confirm code can be run the C2H4 NH3 pH model. Here is what I draw the time complete software shoot detail about use the conflict code. We can see that shoot measurement experiment, the shoot value fraction FV and primary particle diameters dP can be measured by laser incidences TIRE LI system. FV and dP measurements need more than 500 times. Shoot temperature can be measured by spectral shoot emotion SSE technique. The flame temperature can be measured by repeated thermocouple insertion RTI apparatus. TEM imaging and Raman spectroscopy can be measured shoot particular images. Here is the transmission electron microscopy TEM imaging demonstrating the higher absence and larger algemeter size of P85 left panel and Vessel's ground idle condition right panel. So that's all about these 3 parts. So now let me explain the future work plan. For the future work plan, in this September, I will come to this China-UK Low Carbon College, Shanghai Jiao Tong University for the lab this September. It may get some more experiments about soot process results. And the other work plan for the future is choose or design chemical kinetic models. Yeah, that's all about the future work plan. Here is the reference about the provision report presentation. Yeah, that's all. Thank you.